Hello guys, we are back with our next tutorial. As I have told you that will be covering our second unit of basic electronics. So in this tutorial, I'll be going through BJT in depth guys, and I'll be covering all the topics of JFET, and I'll not go in depth on that guys. I'll be going in depth on construction and differences, and I'll be going on CS construction also guys, common source construction. Okay. So basically in this tutorial we'll be starting our BJT. So now let us go through the introduction. So a BJT is a three-terminal semiconducting device in which the operation depends on the interaction of both majority and minority. So here the interaction will be in between the majority and minority carriers. Okay, so that's the reason why we call it as a bipolar. So it's acting on two ways for majority carriers and minority charge carriers. Okay. So these BJT is used in amplifier or oscillator circuits and as switch in digital circuits. Okay guys, so these BJTs or amplifiers, we use them in many circuits. I hope everyone saw my oscillator tutorials in Hartley, Colpitts, RC, and any type of oscillator. We used these transistors guys. So those are the things that give us 180 degrees phase shift. Okay, so I hope now everyone is now got a small idea on BJT. BJT, the full form of BJT is nothing but Bipolar Junction Transistor. Okay guys, okay. Further moving on, let us go through the construction in this tutorial only. There is no time waste here guys, so let us go through it. So the BJT consists of a silicon or germanium crystal in which, so silicon or germanium are our semiconductors, right? So in construction of BJT also we use those semiconductors only. So the BJT consists of a silicon or germanium crystal in which, okay, there are two conditions guys, in which P, a thin layer of N, is sandwiched between two P types. Hence it forms NPN. Sorry, PNP, right? A thin layer of N type is sandwiched between two P types. So PNP is formed. Similarly, if a thin layer of P type is sandwiched between two layers of N type, then it's going to form a NPN transistor. So now let us go through how the diagrams will be for these things. So first let us go through NPN guys. So it is NPN, right? So N is negative, so we will not let negative be with us guys. That's the main condition that I remember for this. So I'll not let negative to be with me, so I'm going to push it out of my circuit. So that's the reason it's going away. Negative means it moves away. Okay, so you can remember like that. So that's the reason why the arrow is like this. And remember one more thing, it is always with emitter guys. Okay, so similarly for PNP, positive things, we want positive things, so we'll be taking them similarly from the E only. E is nothing but emitter, so the three terminals are emitter, base and collector. Okay guys, so now I hope everyone got a small idea on this. So let us go through one more thing and we'll be concluding this, and in the next tutorial we'll be going through operations of NPN and PNP. Okay, so basically the three partitions or the three regions of the transistor are emitter, base, collector, represented as EBC. The arrow on the emitter specifies the direction of the current flow. Okay, when EB junction is forward bias, okay, it's going to show us the direction guys, E. That's what I told you to remember by the names NPN and PNP. Okay, basically the base is lightly doped and the collector is moderately doped. So now I hope everyone is now 100% clear with introduction and some construction of BJT. So in the next tutorial we'll be going through NPN transistor guys. We'll be going in depth in it. Thank you. Thanks for watching.